Welcome back to the lecture on radioactivity. This is part 3. In part 2, we stopped at the properties of gamma rays, number 3 property. And then we're looking at number 4 property now. Number 4 property says, no visible glow is observed when gamma rays come in contact with zinc sulfide. You know, we said that the glow with alpha particle is a bright glow. For beta particle, a faint glow. Gamma ray, no visible glow. That is when each of the radiation comes in contact with zinc sulfide. Let's see key comparison. The radiation we're looking at is alpha, beta, and gamma. The ionizing power, alpha particle has the highest, very high, followed by beta particle, moderate ionizing power, and gamma rays, low ionizing power. So in terms of ionizing power, alpha particle is the highest, followed by beta particle, and lastly gamma ray. In terms of penetration power, remember we said that alpha particles can be stopped by thin sheets of paper. Gamma rays can be stopped by thin sheets of aluminum, and beta particles can be stopped by using thin sheets of aluminum, while gamma rays can be stopped by thick lead blocks. So it shows that alpha particles have the lowest penetrating power, very low penetrating power. So the second is moderate penetrating power and very high penetrating power for gamma. Don't forget, it is alpha, beta, and gamma. So under the penetrating power, alpha has the lowest, beta moderate, and gamma the highest, very high. Effect on zinc sulfide. Alpha particle, which is the first one, produces a bright glow when it comes in contact with zinc sulfide. Beta particle produces a faint glow when it comes in contact with zinc sulfide. However, gamma rays does not produce any visible glow. Now, number 5 property, gamma rays cause low ionization in air. We have discussed that already. Okay, so let's use the less than, greater than sign to describe the ionizing power of the 3 types of radiation. So for ionizing power, we start with alpha particle greater than beta particle greater than gamma rays, or gamma is less than beta and less than alpha. This way of representing the radiation is common when you're writing exams like JAMB or WAEC. Penetrating power. Gamma is leading now. Gamma is greater than beta, and beta is greater than alpha, or alpha is less than beta, and beta is less than gamma. So let's look at a simple calculation. So you will need to listen now. A simple calculation. A radioactive isotope 23592 emits 5 alpha particles, 3 beta particles, and a gamma ray. Calculate the proton number and nucleon number of the daughter element respectively. So you have the radioactive isotope 23592 uranium. Remember, it is emitting 5 alpha particles Alpha particle is represented by writing helium nucleus. So this is helium nucleus, 5 in front. So 5 times 4 is 20. 5 times 2 is 10. So if we do 235 minus 20, that's 5 times 4, 20, that will give us 215. And then we do 5 times 2 is 10. 92 minus 10, that will give us 82. So we bring this here. The next one is that it emitted 3 beta particles. So this is the symbol for beta particle. And then 3 of it. So 3 times 0 is 0. 3 times minus 1 is minus 3. So we have 215 minus 0. That will give us 215. And then we have 82 minus 3. That's 82 plus 3. Minus minus is plus. That will give us 85. And then lastly, this that is then produced emits a gamma ray. So this is now emitting a gamma ray. Remember, for gamma ray, this is the symbol. Once gamma ray is emitted, and of course, we now do 215 minus 0. That will give us 215. 85 minus 0. That will give us 85. You can use any letter to represent each of these. Just could be A, B, C. Doesn't actually matter. Okay, so then this is the daughter element that is referred to in the question. So our proton number then is 85. Our nucleon number is 215. I would like you to go through very well, and then you will do this one for me. The radioisotope 23892 decays by emitting 2 alpha particles, 6 beta particles, and a gamma ray. What is the number of neutrons in the resulting daughter element? This one is not different from the one we did. So you will get the proton number like I did, get the nucleon number like I did, and then to get the number of neutrons, you just do 215 minus 85. So you will use that knowledge to solve your own. We'll meet in part 4.